Hey kids, this is Mr. Pickett. Sorry about the absence today. I had a sick kid, probably about 650. Yeah, it's all right. We're gonna get through with this a little bit today. So what I want you guys to work on is kind of two things. We're gonna take notes, and you can slow this video down as much as you need to. And then when you guys get done with notes, I would like you guys to work on some of the practice that's in your packet, and I will kind of go through where you can find that once we get to it. So without further ado, let's go ahead and get your note packet out, which I think we're on page 24. So yesterday, I just started this, trying to move this around a little bit. And we were talking about dimensional analysis and scientific notation, concept two notes. And if I remember correctly, right, we've talked about dimensional analysis. That's the picket fence kind of method. And we've talked about conversion factors as well. And what is this useful for? Well, baking and cooking, right? Traveling in foreign countries, building or engineering as well. So remember that conversion factors are ratios of values that are the same, meaning that they equal each other. So 24 hours in one day. I know the numbers aren't the same. 24 does not equal one, but the value of 24 hours is the same as the value of one day. So when it's talking about equivalent values, that's what it means. It means that it represents the same amount of something. So how we sometimes write these ratios is like a fraction. So we're going to put one of the values on top and one of the values on bottom. And again, if you take a value and divide it by an equal value, then you're going to get a value of 1 out. 7 divided by 7 is 1. And so we can write these ratios in this way. And again, it doesn't matter which one you do, right? So depending on our picket fence system, right, which again, we're going to call that dimensional analysis. That's the right way to describe it, right? We sometimes will put 24 hours on top, or sometimes we're going to put 24 hours on bottom. All right, 12 inches in 1 foot. So remember and pause and think, what's another way that I can write this as a conversion factor? If you said 12 divided by 1, awesome, making sure you put the correct units, or 1 divided by 12. All right, so what would be the conversion factor for days in a week? So 7 days in a week. So you can write this one of two ways. 7 can go over 1, or the 1 can go over 7. Again, these are equal values. They represent the same amount of time. That's what we're talking about here. However, right, we're using different units, and so we have to keep the units connected with the number. All right, so if we are going to apply this method into a real problem, so we take a starting number and a unit, make your picket fence, and use a chart to fill in appropriate conversion factors, making sure matching units are on opposite sides of the fence to cancel out. And we've done this before. This is just reviewing something that we've covered in class. And what we want to do is we want to multiply the top parts of the picket fences with each other, and then multiply the bottom stuff together. And then divide whatever product you get at the top by the product that you get at the bottom. So how many minutes are in 1 year? All right, well, we'll start with a year. We know that our plan is years to days to hours to minutes. So there's a conversion factor between year and days. So how many days are in a year? 365. Awesome. And then to go from days to hours, 1 day is equivalent to 24 hours. And then how many hours, how many minutes are in hours? 60. What we're going to notice is that we can cancel out year, we can cancel out days, and we can cancel out hours. And so what we need to do next, according to our steps, is we need to multiply all this stuff at the top and get a number, and then multiply the ones together, which is just one, and take whatever number we get at the top and divide it by our one at the bottom. And there's no unit at the bottom because it doesn't exist. So here's our answer, right? 525,600 minutes. All right, so at this point, there's going to be a reference sheet that's going to be color coded, and it's going to have hole punches for you guys. That way, you don't have to memorize all these conversion factors. Here are a bunch of them that are going to be used regularly in class, and this is something that you can use on any assessment that we have. Now, we'll do a couple more examples here. How many feet are in 411 centimeters? Okay, so this is a little bit more of a challenge because we're going to go from the system that you guys are comfortable with, that's feet and inches, and we're going to convert it into our metric system, which is definitely not. So we start with 411 centimeters, and we need to move it over to feet. So you might want to use your reference sheet because there might be a conversion factor in there that's going to help you out. Did you find it? If not, pause the video. Okay, hopefully you found it. So we have centimeters to inches, and then we already know, and hopefully most of us know, inches to feet. So our conversion factor is 2.54 centimeters for every single inch. And again, you shouldn't memorize that. I've got that stuck in my brain because Mrs. Sanders back in, I don't know, 9th grade science when I was 13 or 14 years old. And then how many inches are in feet, or how many inches are a foot? 12 inches into 1 foot. So what we'll do is we'll take 411 times 1 times 1, and we'll get 411 at the top. And then we're going to get 2.54 times 12, whatever that product is at the bottom. And we take those numbers and divide them. We are also going to cancel out centimeters and inches. And that's why we decide to put things, units, where they're at, because we're trying to cancel out things except for feet. Right. So how many feet are in 411 centimeters? 13.5 feet. Now, using your reasonable brain, by the way, right? A meter stick is about 100. Well, a meter stick is 100 centimeters. So if you take 4 meter sticks and lay them, basically end to end, that seems like a reasonable answer, 13.5 feet. Okay. So then we have some practice opportunities for everybody here. Okay. Take a moment. I kind of flashed that first one up there, but try to practice some of these things on your own. Have you paused the video and have you tried number 1? All right, before I click on number 2, pause the video and try number 2. Welcome back. And before you try number 3, pause the video and try number 3. That's if you want to check yourself before you wreck yourself. All right, kids. So up here, by the way, if you have no work shown, it's not acceptable, right? So you need to have the picket fences drawn. You need to have starting out like what you know. So you need to have all of your work kind of set up so that way you can prove that you understand what's going on here. So then we have practice for our dimensional analysis, and I got to refine this. All right. Let's get to that page. All right, so you guys should have, right, basically got up to page like 25. And then on page 27, it says practice dimensional analysis. I would expect all of you to get through 5. So 1, 2, 3, 4, and 5. Right? I don't know how long that those notes are going to sit down and take you, but I would hope that you would get through 1, 2, 3, 4, and 5, as long as this made sense and you guys are getting the hang of this stuff. Please help each other and work. And then on Monday, I'll see everybody. Okay. Enjoy your weekend. don't be afraid to reach out if you guys have questions, but I'll probably be sitting with a bucket with my kiddo today. All right. Bye, guys.